morning, everybody, and welcome to the Amaxra Tech Talk today. Thank you for joining us. We've got an exciting topic today. We're going to be talking about Azure. We're being joined by an Amaxra favorite, Harris Schneiderman and Gavin Barron from Intergen, one of our favorite partners to work with and experts in the Azure field. Thanks, Harris and Gavin, for joining us.
Thanks, Dane. Good morning.
Thanks for having us, Dane. Good morning.
Yeah, absolutely. So I will let you guys kick right into your slide deck so that we can get through this in the next 15 minutes or so.
All right. I thought I'd start with a quick overview of who's Intergen, just for a little bit of background, and then we'll get into the session. So Intergen's a systems integrator. We're publicly listed on the ASX, which is the Australian Stock Exchange. So we have a large presence in Australia, but we also have a number of locations in New Zealand, as well as here in Seattle, Washington. We've got over 1,000 people globally, and just 400 within our division. And the photo there is actually a photo of our office, which is in Wellington, New Zealand. We've won a few awards. We've been a Microsoft partner for decades. We won Microsoft Partner of the Year in 2018, and more recently in 2019 as well. And a lot of the work that we do, as you'll find out, is very focused on Microsoft Azure. We've also won a few awards for some other, platforms as well, like Business Applications, which is Dynamics, and a, Country Partner of the Year award, and an award around data and AI. And that specific solution was built on an Azure platform, which I'm happy to talk about if there's any questions.
So one of the things I really love about the work we get to do with Azure is we get to plan for really high demand systems that have to be highly available and fault tolerant, resilient systems. And that's kind of the focus of what I want to talk to about Azure today, because that is one of the big ways that the cloud is disrupting our industry, is through making it easy to build systems with lower amounts of downtime. Let's be honest, failure's going to happen. It's just a reality in our industry. Things go wrong. Lightning strikes happen. So let's just make sure that we plan for it so we have happy customers and stakeholders. All right. Today we're going to talk about why do we want to plan for failure? What do we use to make a system more resilient? We'll look at a couple of quick demos around how you can take some existing Azure infrastructure and turn it into infrastructure as code, so you can more easily and repeatably deploy systems. And then we'll wrap up. We might look at some automation. We'll see how we go for time. So first of all, why do we plan for failures? Downtime is lost opportunity, simply. If you have a system that has downtime, you're going to have lost productivity for your staff. Potentially, if it's a customer-facing, sales-driven system, you're going to lose revenue for your sales functions. We saw it last year on Prime Day. Amazon had a little bit of a whoopsie and couldn't quite handle their own load. So it even happens to the big players here. The more we can plan for it, the better we're going to be off. Prime Day, frustrated users, because they really wanted to get those deals and they couldn't. Realistically, in the cloud and in every system that we're building, we have to plan for the worst and really hope for the best. It's much better to plan to deal with issues and never have to face them. It's just the way of it. The other thing is, some systems have SLAs. You have to be up 99.99% of the time or available. How that's defined is going to depend on your use case, your business drivers, what the customer expectations are. So the cloud's been such a massive force for change. As we talk about failures and downtime, In traditional IT, we start to think about things like disaster recovery. What do we do when things go wrong? What's our recovery point objective? What's our return to operation? How do we meet those goals? That kind of disaster recovery thinking is very old school versus a more modern approach where we actually design for high availability. We design systems that can tolerate faults and issues and will continue to operate even under certain levels of failure within the system. So, disaster recovery. As you can see from my wonderful drawing here, it's simply an ambulance at the bottom of a cliff. I know it's a bad metaphor, but it really is. We're waiting for something to go, we're planning that something's going to go wrong and waiting for it to happen and then reacting. Whereas planning for high availability, let's put a fence in. Let's stop things falling over the cliff. Maybe a better analogy might be putting people on ropes, but it works. One of these will cost you a lot more depending on which path you take. Sometimes that's goodwill, sometimes it's money. Whichever you're more comfortable planning or spending is the option you want to take. So, if we think about outages and issues, let's think about how much downtime you have within your SLAs. So, we've all heard the nines, 3 nines, 4 nines, 5 nines. 99.9% uptime. Assuming this is a 24/7 system, so production for most customer-facing scenarios, that gives you just over a working day a year of outage time. Less than an hour, 3/4 of an hour a month. Not much time in a week for your system to be unavailable. Then as we stack things up, add 3 nines, we get an hour a year of outage time. 5 nines, 5 minutes a year. That's it. The reactive model of planning for disasters and recovery is not going to meet those higher SLAs under most circumstances. Now, one of the big things to consider as you're planning your cloud deployments is what is the SLA of the service you're purchasing? And what steps do you need to take as you configure and use that service to meet those SLAs? One of the things you also need to consider is what happens if there is a large disaster and say, for example, there's a lightning strike in the middle of Texas and a data center disappears for a while. A whole day. Or maybe there's a thick-fingered engineer who accidentally deletes most of the storage units for an entire service region. These things have happened in the past and have caused massive outages. You want to design a system so that if there's an outage impacting one region or one part of the global cloud that your cloud provider offers, in this case Azure, perhaps you want to make sure that there's some redundancy within your system so that you could fail over to another data center. So that's what we talk about when we're talking about high availability, the ability to have a massive outage and still continue to operate. Now, if you don't plan for these, you're going to wind up just having a terrible time. It's going to be a massive dumpster fire, and you're going to have to deal with management breathing down your neck going, why didn't you plan for this? Not a pretty thing to deal with. So how do we design to avoid that dumpster fire and plan for a resilient system? Well, first of all, we work out what infrastructure we need. Roughly speaking, there's 3 broad categories of services in the cloud you're going to need to deliver almost any system. You need somewhere to store the data for your system, some compute power, so be it VMs or app services, something that does the processing of your data, and some network to actually ensure that that data gets to where it needs to go, whether it's an end user's home PC and their web browser, or to a thick desktop client sitting inside your own organization. So as we look at each of those, data storage, what options have we got for high availability? What have we got for disaster recovery? Considering your trade-offs between, do I take a high availability route or do I take a disaster recovery route? When it comes to compute options, what options do we have around scaling and load management? How do we plan this and ensure that we have resilience across our systems? And what combination of services for our networking are we going to use to make sure that we have continuity of service? So as we step into this a little bit more, I tend to think about this by breaking out what are my global or shared services. Generally speaking, it's going to be things like storage, so where I put my blobs of data, databases for relational or NoSQL based storage options. When it comes to those, we've got to think about what are we going to do in terms of replicating our data across multiple regions. When it comes to Cosmos database, we've got to look at how many regions and which regions are we going to make as writable replicas versus read-only replicas. There are options within Azure SQL for those options as well. They just are more involved and less my area of expertise. Things like app insights to track analytics and our networking options like Azure Front Door, Traffic Manager, that'll help you to scale your system out across the globe. And then we're going to look at, okay, we're going to be deploying into multiple regions because we've just assumed that we're going to go with a high availability route. There's certain services that you're going to want to provision every region. Your compute functions, so your app services, your functions, potentially VMs if you're using IaaS-based stuff, things like Redis caching, because you want to keep those caches nice and close to the place that's processing the cache data. Do you need to consider networking in each of the regions that you're deploying to? Or are you just connecting them using things like Azure Front Door? So are you using VNets? So those are the kind of things you need to think about as you plan out your deployment infrastructure. And I like to separate these into 2 sets of deployments so that it's simpler to manage as I go along. Now, let's take a look at a classic highly available system diagram. This is borrowed straight from Microsoft's documentation. We have the internet, and we've got our users coming in through the internet. They're hitting a traffic manager, which is spreading the incoming traffic across a number of regions. Now, this can be based on things like the location of the user who's browsing that. So people in the US get routed to the West US, and the people in Europe get routed to North Europe, etc. Or maybe it's something like, actually, we're just going to round robin the traffic so that we've got an even spread of traffic across these things. You've got lots of options. And as we drill into within a region, we're going to have a web tier with multiple instances managing the requests within that region, and then maybe a middle tier talking down to a database. Classic N-tier model systems architecture. I look at this, it's great. There's a lot here though. For many systems, this kind of setup is kind of a lot more complex than you need to think about it. It's great if you've got a system like this, go for it. But sometimes it can be broken down to be this simple. Within a region, so I've gone and redrawn this diagram and simplified it. I've gone, we're not going to do end tier because our particular business problem doesn't need that. Just have a single app service per region. Now, app services are great because you can set these up to auto scale up to 20 instances within a region, and that's all managed seamlessly behind the scenes. You just say, hey, these are the rules around scaling. Please do it for me. And then a Cosmos DB that's been configured to replicate across each of your regions. Traffic manager as before, managing incoming traffic and distributing that. So with that kind of broad idea of planning a system in place, let's go and take a look at how we can grab that information out of Azure. Now, sometimes we'll just want to manually configure a system. Maybe we want to do it just because we need to adjust some existing resources within Azure. Maybe it's, hey, we're doing some exploration here and we want to understand exactly how we're setting things up. And sometimes it's just the easiest way to start off. And we can actually use Azure to extract out a template for each of these systems for automation. So we're going to jump over to the Azure portal now and take a quick look at a deployment that remarkably like the one you just saw, but less scaled. Okay, so here we have the Azure portal. I do not have Zoomers installed, so that jumped badly. Anyway, what we have here is a Cosmos DB that's sitting in the West US. I've got a Key Vault that's just for my own deployment purposes, a traffic manager to distribute traffic, and an app service sitting in the West US. Now, let's go take a look at our Cosmos DB. There's not a lot going on here, but if we go into the, where are we? They've moved things on me. Here we go. Replicate data globally. It's just being blind. If I click in here, I can actually just very easily go and say, I would like replicas in these regions. Click, click, reads enabled, writes enabled, boom, done. Click save, it's away. I'm going to discard that. I'm just going to go turn on for, let's use East US. Click save. It'll take a while to set up, replication across that region, but that's all you need to do from the UI. One of the other cool things we can do from within a resource group in Azure, so I've just jumped back to the resource group here, is this export template here. We've gone and manually configured up some resources. We can click in here and here we have the ability for Azure to go and generate for us an ARM template, an Azure Resource Manager template, which is just a structured JSON document, so that we can repeatedly deploy this using Azure PowerShell, Azure CLI, or a host of other options. Really handy stuff. So I can just go download this. It gives me a zip file with a couple of JSON files that I can use to replicate that. This is kind of your stepping off point to templating out an environment. Which is pretty cool because that gives us infrastructure as code. Infrastructure as code gives us a huge benefit because we can automate this. It gives us great benefits. So we can speed up and simplify provisioning environments. It means that test and production and UAT can be configured using the exact same set of code. Consistency of configuration leads to cost savings and more productive staff because it drives down the amount of time you spend configuring an environment, because you just go, yeah, I want one of those environments, please. The fewer changes there are between environments, the lower the risk, right? Every delta between environments is a place where things can be different and therefore introduce risk and change. If you have a bug that only occurs in one environment and you can't replicate it, that's really time consuming to deal with. If you have consistent environments, the odds of that happening are lower. How are we doing for time?
We're doing good, Gavin.
Excellent. Right.
That's probably about 5 or 10 minutes left here. We'll save 5 of that for some questions and some closeout.
Oh, excellent. All right. So, considering that we have now created some infrastructure as code, let's look at another piece of automation that we can use within the Azure toolkit called Azure DevOps to allow us to take this infrastructure as code. I've just shown you how to quickly generate what's called an ARM template using the Azure portal, but you can also use approaches like Azure CLI scripts. Now, let's jump back to my browser. And let's go over here into this browser window. So I've gone and created the world's simplest website. It's a to-do website. Do the things here. Whoa, I can spell today. So I'm going to create this. Now, just to show to you that there's no smoke and mirrors here, we go back into our Azure portal, go up here and into our database. And we're going to go into the Data Explorer. Here we go. That's that to-do that I've just created. Data's saved. Okay, so let's imagine, if you will, that the boss has come along and said, hey, we've got some customers coming in from the East Coast and they're complaining that there's some latency here. You can go, you know what, boss? I've planned for this. We'll spin up some instances over there. So what I'm going to do is jump over to Azure DevOps. What I have here is some deployment pipelines and some release pipelines. I'm just going to go in and quickly edit this demo pipeline. What it is a simple stage that has a few jobs in it and runs a few steps across things. We'll drill into those in a minute. What I would like to do quickly is just update this value so I can deploy into the East US region. I'm going to save that. Because I don't want, I'd like you guys to be confident that this is not just a smoke and mirrors thing. I'm going to quickly go into our home screen. Actually, item. Click edit here. Click commit. Ordinarily, I would never do this. Don't push to master, kids. Always use a pull request workflow. All right, so what's going to happen in the background is I've got some automation here that should have kicked off. Yes, so I've got a job running to build a package that's going to go out and release and update our website. As part of, you saw before, we went into the job and we said, hey, we want to go into the East US. I've got some infrastructure as code that's going to automatically provision an environment to host that in the East US. Let's just take a quick run through of what this does. So you saw earlier in the talk, I was talking about creating shared resources. So we have two stages in this deployment pipeline. The first one, it creates our shared resources. So this creates the App Insights instance. It creates the Cosmos database. And it also creates the key vault that I was talking about before, so that we have a small place to stash some access keys, like the access key for the Cosmos database, because each of those consuming app services needs to know how to connect back to it. Then this next job is actually a parallel job. So we can see down here, uses an execution plan called multi-configuration, and it uses a multiplier called regions. It ties back to this variable over here called regions. And by convention in Azure pipelines, what that does is it takes this value, looks for commas, and splits it into multiple deployment jobs. So we're going to have a deployment job with a value for regions of West US and a deployment with East US. Because I've spent some time to plan my deployments, this job knows how to go and deploy the code and create the app service for that region based on those changes. So there's been a bit of work up front to make this happen, but that investment means that we can easily scale out our system and respond to changes and make sure that we're resilient moving forward. Now, let's see where we're at with this deployment, with this pipeline. Jump back to the pipelines. Cool, we've got a green build. Release is underway. Click into here and we can see, actually, we're already deploying to the West and the East US regions. So this is going to take a little while because we've actually got to create some infrastructure in the East US. So this is using an Azure CLI script. Based on this, it's actually already created our app service. It's just pushing code up there now. We have a step that'll follow this to push the configuration onto the website. So things like the URL of the Azure document DB that it needs to be connecting to, the access keys that it uses to authenticate back and create that connection string to the DocDB or Cosmos DB instance. So that the nice thing about this is that my developers will never ever know what the connection strings are to production systems. Creates a nice separation between development and operations and ensures that we have secure systems and developers aren't going to get unauthorized access to these. You might say, but Gavin, they're being used in these pipelines. Can't the developers come in here and look at those? No, because those values are considered secrets. Within Azure DevOps, secrets are not logged. They are masked out and just displayed as these star, so that it's nice and secure. You can't have a developer get unauthorized access to these values when you don't want them to. We can see here that our deployment succeeded. So it's just turned green in the background. So if we go over here and we'll just refresh, we can see we've now provisioned an app service and an app service plan in the East US. Our site is still up and operational and was running the whole time. And if I refresh this, hey, oh, welcome to a Tech Talk. So you can see we've actually done, the change has been deployed. And I can say, you know what, I think that presentation is almost complete. We'll preemptively start that one. Mark it as complete. So I hope you've found this useful. The one thing I want you to take away today is that building resilient systems isn't that hard when you leverage the power of Azure. It just takes time and planning. There's lots of resources out there to help you on this journey. The documentation from Microsoft's fantastic, but if you want to get in touch with Amaxra or Intergen to follow up on this, please just reach out and get hold of us. Questions?
Yeah, thank you so much, Gavin. I actually had a couple questions for you.
Yeah.
First one being, a lot of our customers aren't necessarily enterprise level customers. Is Azure only for enterprise and big business?
Absolutely not. Azure can scale to suit any business, and often in the small and medium business space, the advantages of Azure are actually really noticeable because the cost of having services becomes an operational expense that you can amortize out over a long time, as opposed to a big bang expenditure on, oh, I've got to buy a piece of infrastructure and hosting. That the costs are really quite attractive to small and medium enterprises.
Great. And then the other question that I actually had for you was, what are some signs that Azure might be a good fit for my business? I mean, if I'm hosting a server or if I'm just going through my daily operations, what are some things that might be a light bulb or a triggering moment for me to say, you know what, I should really look into Azure. Maybe Azure would be a good fit for me and my business.
Oh, there's quite a few. One of the first things I would call out would be, if you notice that you're spending a fair degree of time patching and maintaining server infrastructure for cloud-based operation, or sorry, internet-facing or internal-facing operations, perhaps, especially in the web hosting space, perhaps Azure's a good fit for you there. Do you need to have better disaster recovery for your existing systems? Azure could be a really good fit there, because Azure has means for easing your disaster recovery plans at a minimum, even without going to high availability models.
Okay, great. I think that's all the questions that I had for, yeah.
Yeah, I wanted to add to that too, because I work with a lot of small businesses, and I think there's really two key scenarios where I see small business customers starting to look at Azure. I think one of the biggest ones is if a customer, and there are many today, they're running the majority of their business on an on-prem server, that server is eventually going to need to be upgraded, right? And eventually it's going to reach end of life. So we're, Intergen's helping a number of customers that are in that exact scenario. Then rather than spending thousands and thousands of dollars on a hardware upgrade, that they can spend significantly less money by simply adopting Azure and then removing the need for that 3 to 5 year hardware upgrade cycle. So I think that's one that I see very commonly. And a second one is, more businesses these days are trying to enable both their owners and their employees to be able to work remotely more seamlessly. And I think Azure is a great enabler of that as well. And it'll eliminate a lot of the clunky experience that customers have that they use today, like a VPN or Citrix and things like that, where they can just seamlessly access all of their resources exactly the same way whether they're in the office or whether they're working remotely. So those are some of the scenarios I see very commonly.
Okay, great. Thank you so much, Harris.
And just to add to Harris's point there, it's not necessarily even server hardware that's end-of-lifing. Perhaps you're running a server operating system that's approaching the end of its service lifespan. That could be a really good indicator that, hey, it's time to make a move into Azure.
Okay, great. So basically, anytime a large upgrade would be due, whether it's hardware or software, is a good time to maybe evaluate Azure then.
Absolutely.
Great. Well, thank you so much for you both joining me this morning. We'll switch back over here. As always, with any of our Tech Talks, if you've got any questions, feel free to reach out to myself or the Intergen team. You can use technology@amaxra.com, and you'll always reach someone here at Amaxra. And then we can forward that information along to our friends over at Intergen as well. Join us February 11th for the next Tech Talk. We're going to be talking about backup and why you need it. A lot of people feel that just because you're in the cloud means that you're already backed up, but that might not necessarily be the case. If you'd like to get notifications about any future Tech Talks, you can follow the link there, bit.ly/join the Amaxra Tech Talk to sign up for notifications. And then, as always, we like to get feedback on today's talk, and we like to get new suggestions for talks or topics that you might be interested in. And so you can follow that link there at bit.ly/Amaxra Tech Talk feedback. Thank you both for joining me. I really appreciate the information and the content, and we'll talk to you soon.
Thanks, Dane.
Thanks, Dane.
Bye.